Hi there, I am Carlo Carrano and this is Electronics Engineering Made Easy. In the first episode we have talked about the charge and discharge cycles of a capacitor from the theoretical standpoint. Let's now build actually a circuit and make some measurements to see how really the capacitor work. To do so, we will use a circuit like this. There will be a resistor over here, R. Then we will put a capacitor over here, for which we will take all the measurements. Another resistor here, and soon I will show you what's the meaning of this other resistor. And here. So we will connect a generator over here. We will use a value of about 1 kilo ohm for this resistor and about 10 ohms for this other one. And I chose to use a capacitor of 0.1 microfarad to take the measurements. Initially, I will attach here a generator that will basically generate a voltage that works this way. When the voltage goes up, it will charge the capacitor, and when the voltage goes down, it will discharge the capacitor. We should be able to put an oscilloscope between these 2 points, and with that we should be able to measure the voltage at the capacitor. Considering that this resistance is really small compared to this one, the voltage that we lose on this resistor should be very small, so the voltage between these 2 points, 1 and 2, should be close enough to the one of the capacitor itself. Now, why there is this resistor over here? Because in a second kind of measurements, I will use this connector 3 to measure again a voltage between these 2 points. But this voltage here will be proportional to the current that flows in this resistor. So basically this will be the equivalent of measuring a current throughout the capacitor. So we measure the voltage, we divide it by 10 and we obtain the current actually. I had to do this way because when you use an oscilloscope you have to be careful where you put the ground on the oscilloscope. You cannot put everywhere you want in the circuit, otherwise you will short circuit pieces of the circuits. So the only way to measure the current with an oscilloscope is to make it flow through a resistor and measure the voltage around the resistor. So that's what I'm going to do. So without any further ado, let's build this circuit and let's run some measurements and see what we get. I'm going to build a circuit on this breadboard. So I will start definitely by putting the resistor of 1 kilo ohm on the board, like this. Then I will put the capacitor. Which is connected to the same resistor, and then we'll put it over here. There we go. Then the 10 ohm resistor will be over here. Then the 10 ohm resistors go to the ground. So let's use this rail over here for the ground. So I'll put the resistor directly there. And then the other resistors goes to the generator. Let me move this resistor over here. Okay, so resistor, so from generator to resistor to capacitor to other resistor to negative of the power supply. So let me put this to simplify the connections with the oscilloscope. One here for the positive rail where the generator is located, and this is the ground rail instead. Okay, so for this circuit I'm gonna use this device here, which is my generator, in which will basically create a square wave. I will use this function generator to charge and discharge the capacitor with a square wave, and then we will see the information coming out on the oscilloscope. In particular, on one trace we will see the voltage between these 2 points, and on the other track I will put the generator, so we can compare input and output to see how this behaves practically. Once we've done that, I will move this connection to this point over here, so we will check the current of the capacitor when it's charged and when it is discharged, and see how it is different from the voltage charge and discharge. We can compare also them directly one with the other. So let's do this one at a time. So first of all, I'm gonna connect the channel 2 on the oscilloscope to the capacitor. So ground side and other terminal of the capacitor, and I will use the other channel of the oscilloscope, channel 1, between the positive rail, which is basically the one that will be powered by the function generator, and ground again. And then I will attach the connector of the power generator between this point, which will provide the voltage to the capacitor, and ground again, which we can put it over here. So let's take a look now at what the oscilloscope is telling us. Let me adjust here a little bit. There we go. So we can see the yellow one is the generator that powers the capacitor, and the blue trace is the charge cycle over here and the discharge cycle of the capacitor over here. You can see that when the voltage is applied to the capacitor starts charging very quickly at the beginning, and then slower and slower and slower until it reaches the maximum charge. Conversely, when we short the wires of the capacitor will initially discharge very quickly, and then slower and slower and slower until it is totally discharged. Why that happens? Well, think about it. When the charges start accumulating on the capacitor, a voltage starts to increase on the capacitor itself, and this is actually the voltage that we see. But the current that goes through the capacitor and that charges it depends on the difference of potential between the voltage applied with the generator and the voltage the capacitor already has. So once the capacitor keeps charging, this difference of potential will be reduced further and further and further, and so less and less charges will reach the capacitor in a certain interval of time, and so the capacitor will start charging slower and slower and slower until it stops charging totally. Vice versa, when we short circuit it, again at the very beginning the difference of potential would be maximum. It's the top over here and then zero on the other side, and then it will start decreasing slower and slower and slower, because since the difference of potential becomes smaller and smaller, the current that through the resistor that charges and discharges the capacitor will become lower and lower and lower. So we talk about the current. Let's see actually how the current behaves. So let me disconnect here the oscilloscope from the capacitor, and let me connect it on this resistor so we can measure actually the current that flows into the capacitor. Let's go back to the oscilloscope. Let me adjust now here. Here we go. Let me overlap these two lines so we will see exactly what happens. You see again, the voltage is given by the yellow line. This is the power that the power supply for the capacitor, and the blue this time is the current through the capacitor. You can see at the very beginning, since the capacitor is totally discharged, there will be the maximum difference of potential on the resistor R1 that we saw before, so there will be the maximum flow of current, which will shut up to the maximum possible imposed by the resistor. Then, while the capacitor keeps charging, the current will start reducing until it goes to zero entirely. This is when the capacitor is completely charged. Conversely, when we short the capacitor, then there will be a peak of current in the opposite direction, because now is the capacitor that is moving the current across the resistor in the opposite direction, and we will see over here. And then the current will keep going until it reaches zero, when the capacitor is completely discharged. Let's compare now directly the voltage of the capacitor and the current of the capacitor. So I'm gonna move now the channel where I measure the voltage from the generator directly onto the capacitor. Let's go back. Let's see what happened here now. See, now the yellow line is the one that represents the voltage across the capacitor. The blue line is the one that represents the current across the capacitor. You can see there is at the very beginning a peak of current and the capacitor starts charging, so the voltage starts increasing, and while the voltage increases, the current decreases until the capacitor is fully charged, so it has reached the maximum voltage and there is no more current flowing into it. Then we switch off the generator, so we short circuit the capacitor through the resistor R1, the 1K that we saw before, so there will be a peak of current in the opposite direction, because now it is the capacitor that is making flow the current across the resistor in the opposite direction as before, and the voltage across the capacitor will start decreasing. And while the voltage decreases, the current decreases too, negatively of course, until the capacitor is completely discharged around this, and then the voltage and the current will be both zero. So that's all I wanted to show you today, and next time when we talk about capacitor, we will talk about some more information about the behavior of the capacitor in terms of alternate currents and how it is used in various situations.